Hey, let's talk about equations of lines in the coordinate plane. But before we do that, let's talk about skiing. If you've ever been skiing, you might have noticed that there are different symbols that represent how steep a hill is. Black diamonds represent the steepest ones. And if there's a really bad one, they'll do like a double black diamond. But if we just wanted to rate these three slopes, how would we rate them? How would we figure out which one's the steepest? Just by looking at them, it looks like this one's not quite as steep, but I can't be really sure just by looking. But we can find out with a little something I like to call math. We can ask ourselves, alright, so if I go over 3,300 feet, I'm going to go up 1,190 feet. So how much up do I have per foot? If I can measure each one of these in up per foot, then I can know which one's the steepest. And a measurement that we use for that is called slope. You may have heard of the term, the phrase, rise over run. Well, that's what how we calculate slope. So if we say, what's the rise? That's 1,190 over the run, that's 3,300, and then 1190 divided by 3,300 is about 0.36, approximately equal to 0.36. And remember, any number you can think of as a fraction over 1, so that means that we would go up 0.36 feet every time we go over 1 foot. So the higher this number is, the more steep it is, because this is how much you're going up per 1 foot that you go to the right. So if this number is higher, then you're going up more as you go 1 foot to the right. So let's see what that number looks like for B. We go up 1,180 feet. When we go over 300 feet, or 3,000 feet, 1180 divided by 3,000 is about 0.39er. So this is about 0.39, which means this is a little more steep than A is. Well, how about slope C? We go up 1,150 feet. When we go over 3,500 feet, 1150 divided by 3,500 is about 0.33. So, looks like B is the most steep. So slope B gets the black diamond rating. And then A is the second steepest. So slope A will get the blue square. And then C is the easiest. So slope C gets the green circle rating. Cool. So you can graph a line and its equation when you know certain facts about the line, like the slope and a point on the line. So the slope, m is the letter we use to represent the slope of a line. It's the ratio of the vertical change to the horizontal change between any 2 points. Rise over run. So if you got 2 points, the x value of the first point, the y value of the first point, the x value of the second point, the y value of the second point, you can find the slope, rise over run, by subtracting the y values, because y measures up and down. So y2 minus y1 tells you how much it went up or down between those two lines, over the run, which is the difference of the x values. x2 minus x1 tells you how far it went from side to side. So this gives you that value. And on the diagram, here's your x2, y2, your second point, your first point. y2 minus y1 tells you how far it goes from the top down to the bottom. x2 minus x1 tells you how far it goes from left to right. Let's do an example. What is the slope of line B? Let's see, here's line B. Here's a couple of points on line B. We got negative 1, 2, and 4, negative 2. So we're going to do the difference of the y values. So they did 2 minus negative 2. These are the y values, 2 and negative 2. So 2 minus negative 2. And then the difference of the x values going in the same order. We started up here. We're starting with this point. And then we are subtracting this point. So we did 2 minus negative 2. That means we have to do negative 1 minus 4. It's important that you get those in the right order. Okay, well 2 minus negative 2 is 2 plus 2, which is 4. Negative 1 minus 4 is negative 5. So the slope is negative 4/5, which means you go down 4 units when you go to the right 5 units. And that makes sense. Look, you go down 1, 2, 3, 4 units. You go to the right 1, 2, 3, 4, 5 units. And that's how you get from this point to that point on the line. So what about the slope of line D? Well, here's line D. And here are 2 points on line D. And we'll do the top point minus the bottom point. So the y values go on top, 0 minus negative 2. And then the x values go on the bottom, 4 minus 4. 0 minus negative 2 is 0 plus 2, which is 2. 4 minus 4 is 0, and you're never allowed to divide by 0, so that is undefined. So we can't say what the slope of this line is because it is undefined. So vertical lines have undefined slope. Okay, so pause, use this here picture to see if you can find the slope of line A and the slope of line C. Okay, so for the slope of line A, I'll use this point here and this point here, and I'll do the top point minus the bottom point. So the y value minus the y value. This is for A. 7 minus 3 goes on the top, and 5 minus 2 goes on the bottom. 7 minus 3 is 4. 5 minus 2 is 3. So my slope is 4/3. Slope you generally want to leave in an improper fraction. You don't want to say the slope is 1 1/3 because that takes away your rise over run. It's easier to see how the line behaves looking at it as an improper fraction. Oh, I go up 4 when I go to the right 3. So I go up 1, 2, 3, 4 when I go to the right 1, 2, 3. And there's my 2 points on the line. Alright, so part B is what's the slope of line C? Line C is here. And I'll do, say I'll do this point, take away this point. So I'm going to do y's on the top, 7 minus 7. X is on the bottom, 1 minus 5. 7 minus 7 is 0. 1 minus 5 is negative 4. And 0 divided by negative 4 is 0. So my slope of a horizontal line is 0. Slope of a vertical line was undefined. And that's always going to be true. Every vertical line is going to have undefined slope, and every horizontal line is going to have a 0 slope. So we can have positive slopes that go uphill from left to right. We can have negative slopes that go downhill from left to right. We can have 0 slopes that don't go up or down as it goes from left to right. And we can have undefined slopes that go up and down. One way I remember it is, I pretend I'm going to write a word on the line. And if the word is going to go uphill, then that is positive. If the word's going to go downhill, then that slope is negative. If the word is just going to be flat, it's not going up or down, that's 0. No change in height. And then if it's straight up and down, my word is not going to stay on that line. It's going to fall. Ah, that's undefined. Okay, so here's something for your notes. Slope-intercept form of an equation of a non-vertical line is y equals mx plus b, where m is the slope, so whatever number's in front of x is your slope, and b is the y value of the y-intercept. In this book it keeps saying that b is the y-intercept, but the y-intercept is actually the point 0b. So b is the y value of the y-intercept. So y equals mx plus b, where m is the slope, and b is the y value of the y-intercept, which is the point 0b. And then we got point-slope form. Point-slope form goes y minus the y value of the point you have equals the slope of x minus the x value of the point you have. You got to have a slope and a point in order to use point-slope form. Kind of makes sense. Just like in slope-intercept, you need a slope and a y-intercept to make slope-intercept form. Sometimes names are just really, really fitting. So if you have your point, x1, y1, and your slope, you can write an equation by saying y minus the number that's your y value of your point equals the slope times x minus the number that is the x value of your point. And your secret phrase is chicken feathers. Okay, so problem 2. What is the graph of y equals 2/3 x plus 1? How am I going to do that? Well, this is in slope-intercept form. Y equals mx plus b, so m is my slope, which is 2/3, and b is the y value of my y-intercept, which is 1, so my y-intercept is the point 0, 1. So now I can start graphing. You always begin with b and then move with m. So I'm going to begin with b. My y-intercept is 1, so that's the point over 0 up 1 on the y-axis. And then I'm going to move with m, 2/3, so my rise over run is 2/3, which means I'm going to go up 2 as I go to the right 3. It's a positive slope, so I should be going uphill from left to right. So up 2, to the right 3, and there's my next point. The coordinates of that point are from the origin over 3, up 3. Once you got 2 points define a line, so draw a line. Bada boom, bada bing. And you can see that even from this point, if you go up 2 over 3, there's another point that's on that line. Up 2 over 3, there's another point that's on that line. If you go over here, if you go down 2 and back 3, there's another point that's on that line. Down 2, back 3, another point that's on that line. Does that make sense that you should be able to go up 2 to the right 3 is the same slope as down 2 and back 3? Why does that make sense? Well, up 2 to the right 3 is 2/3. Down 2 to the left 3, down 2 is -2 for the rise. And then left is also negative, so left -3. And what slope is that? Negative divided by negative is positive. So no matter which way you think of it as up to the right, down to the left, a positive slope is always going uphill to the right. Bing. Ooh, this one is in point slope form. So my slope is -2, and my point is, let's see, x minus the x value of my point. So x minus -3 is x plus 3. So that means that my x1 is -3. And then y minus y1, y minus 3, so my y value is 3. So my point is -3, 3, and my slope is -2. So how am I going to graph that? Well, here's my point where I can start. So I'm going to graph that point, -3, 3. My slope is -2. Well, how do I think of that in terms of rise over run? Any number you can consider it as being divided by 1. So you can write it as a fraction by just putting it over 1. What's negative 2 divided by 1? Negative 2. So this is the fraction version of the number negative 2. So that means I'm going to go down 2 when I go to the right 1. So down 2 to the right 1. There's my point. That point is negative 2, 1. And I draw me a line through there. Boom. Pretty nice. You didn't know I could draw straight lines like that, did you? Alright, let's see if you can do it. See if you can graph. Grab some graph paper. See if you can graph that. Then push play when you want to see me graph that. Graph that. Whoa. Okay, so y equals 3x minus 4. For y equals 3x minus 4, my slope is 3, which means 3 over 1. And my y-intercept is 0, negative 4. So I'm going to start at 0, negative 4. And then I'm going to go up 3, right 1. Up 1, 2, 3 to the right 1. So I'm at the point 1, negative 1. And draw a line through them. Alright, for the graph of B, my slope is negative 1/3. And my point is, let's see, it's x minus x1. So x1 is 4. And it's y minus y1. So y1 is 2. So I will start at the point 4, 2. And then my slope is negative 1/3. So I'm going to be going down to the right. Down 1 to the right 3. Down 1 to the right 1, 2, 3. And then draw a line through those 2 points. If you want to make sure your line is good, you can go down 1 over 3, down 1 over 3, make some more dots. You can go back 3 up 1, make a dot, 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 and then draw your line that making sure that it goes through all those points. I speak the English language. So what is an equation of the line with a slope of 3 and a y-intercept of 0, negative 5? Well, I have a slope and a y-intercept, so I can use slope-intercept form. And all I have to do is substitute the slope in for m and the y value of the y-intercept in for b. So y equals 3x plus negative 5, and then that's 3x minus 5. Cool. What is an equation of the line that goes through the point negative 1, 5 with a slope of 2? Well, this is my x1, y1, and my m equals 2. I have a point and a slope, so I'm going to use point-slope form. And I'm just going to substitute in my values. My y1 is 5, my m is 2, my x1 is negative 5, so I get y minus 5 equals 2 times x minus negative 1. Minus a negative 1 is plus 1, so I get y minus 5 equals 2 times x plus 1. Ooh. Let's see if you can figure out an equation for these lines in this here. Got it. And then pause it, push play when you're ready to see it done. Okay, so for A, I have a slope and a y-intercept of 0, 2. So I'm going to use y equals mx plus b. That's my point-slope form. Y equals, the slope is negative 1/2. So negative 1/2 x. And then my b value is 2. So plus 2. And I'm done. On B, I have a point and a slope. So I'm going to use point-slope form, which is y minus y1 equals m times x minus x1. So y minus the y value, which is 4, equals the slope, which is negative 3, times x minus the x value, which is negative 1. Well, when I do minus a negative 1, that's plus 1. So this turns into y minus 4 equals negative 3 times x plus 1. Sometimes you just got a graph, and you got to look at the graph and figure out the equation of the line. Well, I got 2 points on my graph. So I can use those 2 points to find the slope of this line, and then I can use one of those points in the point-slope formula. So here's what I'm going to do. Find the slope. M is y2 minus y1 over x2 minus x1. So I'm going to do 5 minus negative 1 over 3 minus negative 2. Minus a negative 1 is plus 1, so that's 6. And then 3 minus a negative 2 is 3 plus 2, which is 5. So my slope is 6 over 5. And I can just check and make sure that I go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. Bing! Now I can pick a point. I will pick the point 3, 5 so that this question makes sense later. So my point is going to be 3, 5, and then I will do y minus y1 equals m times x minus x1. Y minus the y value, which is 5, equals m, 6 over 5, times x minus the x value, 3. That is an equation of the line in that graph. So let's see if you can figure out 4a and b, and then push play when you're ready to see the answers. Okay, so A, what if we used this point instead of 3, 5 in the last step here? So y minus y1 would be m times x minus x1, but now I'm using negative 2, negative 1 instead. So it would be y minus negative 1, which becomes plus 1, equals the same slope times x minus the x value, which is negative 2, minus a negative 2 is plus 2. So that would be the equation using the other point. Now part B says to rewrite each of these in slope-intercept form and then compare them. Well, alright, let's do it. So, to change this into slope-intercept form, I just need to distribute and then subtract 1 from both sides. So, when I distribute, I get y plus 1 equals 6 over 5x plus 2 times 6 over 5 is 12 over 5, because 6 times 2 is 12. Then if I subtract 1 from both sides, let's see, these will cancel and I will get y equals 6 over 5x plus 12 over 5 minus 1, but I want to write this with a denominator that I can use for subtraction. So 1 is the same as 5/5. So then we get to simplify 6 over 5x, and then 12 minus 5 is 7, so plus 7/5. So this is slope-intercept form from this equation. Now we need to get slope-intercept form from this equation, and we follow the same steps. We're going to do y minus 5 equals, and then we're going to distribute 6 over 5x minus 6 times 3 is 18, so 18 over 5. Then we're going to add 5 to both sides. So we're going to get y equals 6 over 5x, And then 5 is 5 over 1, right? And if I multiply the top and bottom of that, I get 25 over 5. So 5 is the equivalent of 5 equals 25 over 5. I think we can all agree to that, right? So instead of plus 5, I'm going to do plus, so plus 25 over 5. Now with a common denominator, I can just do negative 18 plus 25, which is 7. So I get 6 over 5x plus 7 over 5. What do you notice about slope-intercept form? Doesn't matter which point we use to get our point-slope form. When we change it into slope-intercept form, it'll always be the same because there's only one y-intercept for a line. And that's the truth. Alright, so how do we write equations for horizontal and vertical lines? Well, I know that horizontal lines have a slope of 0. And I know vertical lines have a slope that's undefined. Let's see, what do we know about this? Let's think about this. Every point on the horizontal line, so every point on the horizontal line has a y-coordinate of 4, right? This one here is over 2 up 4, over 1 up 4, over 0 up 4, back 1 up 4. The y value is always 4. So the equation of this line is y equals 4. X can be whatever it wants, but y is always 4. You can think about that in terms of slope-intercept. What's the slope of this line? The slope of this line is 0, right? The slope is 0. So if you were doing y equals 0x plus, where does it hit the y-axis? At 4, because every y value is 4. 0x is 0, so y equals 4. What about this vertical line? What do you know about every point on this vertical line? Over 2, up 0. Over 2, up 1. Over 2, up 3. Over 2, up... What am I just saying? I'm saying weird things. Over 2, up 0. Over 2, up 1. Over 2, up 2. Over 2, up 3. Over 2, up 4. The x value is always 2 on this line. So, x equals 2 is the equation of that line. Y can be whatever it wants, but x always has to be 2. So, horizontal lines are always y equals whatever number the y value is for that line. And vertical lines are always x equals the x value of every point on that line. So, see if you can figure out the equations for these lines. We kind of already talked about B up here, didn't we? So for A, if it's going through the point 4, 3, this is the x value, this is the y value. The equation for the horizontal line is going to be y equals negative 3, because that's going to go right here. Think about that line. All the y values are negative 3. And then the vertical line is going to be x equals 4. And that would go right here. Vertical line, all the x values are 4. I can draw straight lines, and then here's your point, over 4, down 3. This is 4, negative 3. Cool. Hey, we're done. I will see you on the flip-flop.